In section 5.1, we're looking at the introduction to polynomials and polynomial functions. So the first thing is, what is the definition of a polynomial? A polynomial is a finite sum of terms in which all the variables are raised to non-negative integer powers. So that's important. We can't have -1, we can't have -100 as our power. We can only have non-negative. And no variables may appear in any of the denominators. The three most often seen polynomials are a monomial, which has one term, a binomial, which has two terms, and a trinomial that has three terms. The degree of a term is the sum of the exponents on the variables contained in the term. The degree of a polynomial is the largest degree of all of its terms. So we want to name the type of the polynomial and give its degree. So the degree of 5x to the 6th is 6. The degree of the 3x squared is 2. And the degree of just a constant, any constant, is 0, because it doesn't have any variables attached to it. We also know that this is a trinomial because we have three separate terms. So that's the type. It's a trinomial. And the degree is whatever the highest degree present, which is 6. Let's go ahead and try the next one. 7x plus 6. Remember, if there's no exponent written on our variable, it's a 1. So the degree of 7x is 1. And we know that the degree of any constant is 0. We have two terms here, 7x and 6, which makes this a binomial. And this is going to be degree 1, because that is the highest degree that's present. Let's try something a little bit more complicated. First off, let's just see what type of polynomial it is. We have 1, 2, 3 terms. So this is a trinomial. And we need to figure out the degree. We have multiple variables going on here. So how we do this is we add their exponents together. So the degree of this first term is going to be 2 plus 1, which is 3. The degree of the second term is going to be 4, or 1 plus 3. And the degree of the last term is 1 plus 1, or 2. So the degree of the entire polynomial is 4. For part D, we only have one single term, which makes this a monomial. And what is the degree of that one term? Again, we want to add the exponents together, 4 plus 5, which gives me 9. So this is a degree 9 polynomial. What about the next one? In the first term, we have a -3. But what did I say about a polynomial to begin with? I said that we have to have non-negative integers. And no variables can appear in the denominator for it to be a polynomial. But that is clearly a negative integer. So this is not a polynomial. What about for part F? This one breaks the other rule that I talked about, and that's because the x and the y are in the denominators, and we said that couldn't happen. So this is also not a polynomial. And then we have 4ab to the 1/2. So you probably guessed it, there's something funky with the fact that we have a 1/2 power. And that's because we said it has to be an integer, a non-negative integer. And 1/2 is non-integer. So this is also not a polynomial. So you can kind of see the difference between what polynomials look like and what polynomials are not allowed to look like. And so a polynomial in x is an expression of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 all the way down until a to the 0 or a sub 0, where n is a non-negative integer and the constants are real numbers. We write the exponents on the variables in descending order from left to right. So adding and subtracting polynomials is just combining like terms. So let's look at example number 2. We need to find like terms. We have 5x squared and -3x squared. We have -3x and -7x. And we have -8 and +9. So 5x squared minus 3x squared gives me 2x squared. -3x minus 7x is -10x. And -8 plus 9 is going to give me +1. Now subtraction is just like addition. This should be a minus sign in the middle. The first thing we need to do, though, is we need to distribute the negative power to all of the terms in the second polynomial. Once we've done this, it just becomes a combination of like terms, just like with addition. So your first polynomial is going to stay exactly the same. You can just drop the parentheses. And then in the second one, we're going to change the signs of everything. So minus 3x squared plus 4x minus 13. And so now we want to combine like terms. We have -5x squared and -3x squared. We have -19x plus 4x and 15 and -13. So -5x squared minus 3x squared gives me -8x squared. -19x plus 4x is -15x, and 15 minus 13 is +2. And let's talk about multiplying polynomials. We're just doing distribution how many ever times we need to. So in this case, we're going to distribute the 7x squared to both pieces. And then we're going to distribute the -8 to both pieces. So let's go ahead and write this out. We have 7x squared times 2x plus 7x squared times -3. Now we want to distribute the -8. We have -8 times 2x, and we have -8 times -3. And so you'll notice that inside the black parentheses, the numbers were the same. The ones that changed were the numbers in the colors on the outside. So 7x squared times 2x is going to give me 14x cubed. 7x squared times -3 is -21x squared. -8 times 2x is -16x. And -8 times -3 is plus 24. And we just want to make sure we don't have any like terms to combine, and we don't. So this is going to be my final answer. We do have some special forms, but you don't have to memorize these because all of these can be solved with just distributing like we did in the previous multiplication problem. If you do memorize them, they will make your life easier. So I am going to show you both ways, one with the formula and one with just the regular multiplication. The first special form is the sum and difference of two terms. If I have a plus b times a minus b, I end up with a squared minus b squared. If I have a minus b squared, I end up with a squared minus 2ab plus b squared. And if I have a plus b squared, I end up with a squared plus 2ab plus b squared. So first, I'm going to multiply just how I did in the previous problem. I'm going to distribute the 2x to both pieces, and then I'm going to distribute the -9y to both pieces. So we have 2x times 2x, and we have 2x times 9y. I have -9y times 2x, and I have -9y times 9y. So we end up getting 4x squared plus 18xy minus 18xy minus 81y squared. We have our like terms in the middle, but these end up canceling, and we're just left with 4x squared minus 81y squared. So I didn't utilize the formula at all. I just went ahead and multiplied this out. So if you ever get stuck, you can always just multiply. If I was to use the formula, in this case, my A would be 2x, and my B would be 9y. And so we know we're supposed to get a squared minus b squared. And so we end up with 2x squared minus 9y squared. We have to make sure that we distribute the square to both pieces since we have a multiplication going on. And so 2 squared gives me 4, we have x squared, and 9 squared gives me 81, and we have y squared. So you see that we get the exact same thing. The formula was of course shorter because you missed all of the extra steps. So if you want to memorize it and you feel comfortable doing so, that's great. Especially this one we use all the time. But again, if you get stuck, you can always just refer back to multiplication. Now for these ones, if you wanted to utilize multiplication, you have to make sure that you write it out twice, because that's what squared means. We can't just distribute the squared to both pieces because we have an addition or subtraction inside. In order to distribute the square to both pieces, we need to have multiplication or division. So first thing you want to do is you're going to write 5x minus 8y times 5x minus 8y. And from here, then you can multiply as normal. I'm going to assume that you know how to do that. So let's go ahead and just use the formula. So my a in this case is 5x, and my b is 8y. What we're supposed to get is a squared minus 2ab plus b squared. And so plugging in, we end up with 5x squared minus 2 times 5x times 8y and then plus 8y squared. Again, you want to make sure you distribute the 2 power to both pieces. And so we get 25x squared. We have negative 2 times 5, which is negative 10, and negative 10 times 8 is negative 80. And we have xy plus 8 squared, which is 64, and y squared. And we have one more. You can approach this again with the multiplication way by writing it twice and then distributing twice, or you can use the formula. So I'm going to use the formula for this. We have a, which is 3u, and we have b, which is 11b squared. We should be getting a squared plus 2ab plus b squared, which is just 3u squared plus 2 times 3u times 11b squared plus 11b squared squared. We got to make sure that we distribute that power to both pieces. And so what we end up with is 9u squared plus 2 times 3, which is 6, times 11 is 66. We have u and v squared, and then 11 squared gives me 121. And we have b squared squared. And when I have a power raised to a power, we multiply the powers, so we end up with b to the 4th. And let's go ahead and try one more multiplication problem. We don't have a formula for this, you just have to understand how multiplication works. So what we're doing is we're just distributing 3 times. We're going to distribute the 4x squared to both pieces. We're going to distribute the negative 2x to both pieces. And then we're going to distribute the 3 to both pieces. So we have 4x squared times negative 3x plus 4x squared times 4 Then we have negative 2x times negative 3x. And we have negative 2x times 4. And the last distribution, we have 3 times negative 3x. And then we have 3 times 4. And so we want to multiply this out and combine like terms if possible. So we end up with negative 12x cubed plus 16x squared plus 6x squared minus 8x minus 9x plus 12. We have some like terms. We've got 16x squared and 6x squared, and we have negative 8x and negative 9x. So we end up with negative 12x cubed plus 22x squared minus 17x plus 12 as our answer.